explain the solution for question number 1. So the question number 1 is this, and the solution is right here. So according to what I've drawn on this paper, which is the graph, you should understand this. This both tens is in the equation, is in the function, and this 1 and 2 is the limit. So the function given is an odd function, so we will use the formula for odd function as shown. So to find Bn, the equation should be like this. 2 is fixed, and 2 should be over T0. So given T0 is equals to 2 seconds, W0 equals to 2 pi over T0. And yeah, let's solve this question now. So the step 1, substitute the given T0 2 seconds into the equation, and also substitute the function 10 as stated just now into the equation. So step 2, after dividing 2 by 2, we should get a 1, and we are going to integrate this equation respect to t. So we'll bring nw0 out of the bracket, also 10 out of the bracket. And the next step will be, we are going to integrate now. We are going to substitute the limit as given at here and here into the equation. So after substituting these limits into the equation, we should be getting like this. And finally, after calculating everything, we should get an equation like this, final equation. And the answer would be 40 over n pi. So the Fourier series for ft will be 40 over n pi sine n pi t. Thank you. That's all for me.
Madam, my name is Rustiana, and I will continue Faizah part, which is I will present question 1. This is the Fourier series for ft. We already know that ft is a half-wave symmetric signal, so only odd harmonics will be present like this. This is question 1, and then this is the general equation of steady periodic solution. Where this will be equation 2. And equation 3 is the general differential equation for spring mass system. And then we need to substitute value of ft and SSP in equation 3 from equation 1 and equation 2. This is the given information from the equation. M equal to 2g and k equal to 32. and then after we substitute, we'll get like this. This will be equation 4. So the steady periodic from equation 2 and equation 4, this is the answer. Thank you. Thank you. That's all for question 1.
I'm Amelia. Now we're going to discuss about question 2. Now let's get started. So the question asks, if the length of the string is 10 cm with the amplitude 5 cm was set initially, state the initial condition and the boundary condition for the problem. The hints are given. Fx equal to Bx for the limit is 0, x 1 over 2, and Fx Bl minus x for the limit in 1 over 2 and 1. So as given, L equal to 10 cm. It said here the length of the string is 10 cm, so the L is equal to the 10 cm with the amplitude of 5 cm. So 1 over 2 BL equal to 5 amplitude here. So now we substitute the L that we got from the question, which is 10. 1 over 2 BL, which is 10, equal to 5. So we get B is equal to 1. Now we are going to answer the question, which is the initial condition. 0 is we get from the initial, which is 0, and the 10 is from the length, the maximum length that we got. So both are equal to 0, and here we got u equal to u bracket x 0 equal to fx. So here is the limit, the function and limit that we got from here both. So x, here we got b is 1, so 1 times x is x. Okay, so here is the limit, 0 less than x less than 1, L over 2. So L is a 10 over 2 equal to 5. Okay, next is a 10 minus x, which is we got from here, b times L minus x. B times L, b times x. So b times 1 is a, this is x, so b times L is 1 times 10, because b is 1, L is 10, so 10 minus x, x is no value. Okay, so 1, which is b, times x, we get x. So the limit we got from here, 1 over 2, L over 2, so L is 10 over 2, still got the same answer, equal to 5. Okay, 5 less than x less than 10, L is 10. Okay, now we move to the boundary condition, utx 0 equal to 0, because the resting time is t equal to 0. Thank you.
I'm Fadiana and I will continue with the next question, which is question B. Provides that the wave equation model for the physical problem is ut equals to 4 utt, where x is between 0 until L and t is greater than 0. Solve the wave equation using finite difference method for 0 is less than and equals to t and t less than equals to 0.5 by taking hash equals to 1 and k equals to 1.1 over 4. And this is our general equation. From that, we solve to get the time equation where k is a constant. Okay, then we use case 3, which is k is less than 0 and the value of k less than 0 is negative lambda squared. So we solve to find the root using second ODE. So we will get complex conjugate roots, and the equation is x a cos lambda x plus b sin x. Okay, next for initial condition, where u0t equals to 0, which is x0 is 0. So we substitute the value of x here to this equation, so we will get a equals to 0. So x equals to b sin lambda x. Okay, for second initial condition, where u10 t equals to 0, where x10 equals to 0. Okay, we take the condition where x10 equals to 0. x10 equals to b sin 10 lambda. So from this equation, b sin 10 lambda equals to 0, but b is not equals to 0. So we move this b into the right side and we will get the value of lambda, which is n pi over 10, and we get the value from this graph, sin lambda x graph, which is we know this is the first n lambda, second n 2 pi, first n pi, second is 2 pi, and third is 3 pi, and the fourth is 4 pi. This is we can choose to evaluate the n value. So the equation goes to xn, x equals to bn sin n pi over 10x. Okay, next we find the roots for t double prime over 4t equals to negative lambda squared. So we will get complex conjugate also. Our equation goes tn cn cos n pi over 5t plus d sine n pi over 5t. This is when we substitute the value of lambda. Okay, so here we use Cn and D because to differentiate from the first equation. Okay, the equation will be U as n Tn, which is we need to multiply both equation and we will get U as T sine n pi x over 10 Pn cos n pi t over 5 plus Qn sin n pi t over 5, which is we use the Fourier series equation to minimize the number of unknown. Condition, which is u at 0 when t is 0. So the piecewise function for x, fx is x greater and equals 0 and x less than and equals 5. And the second is 10 minus x, which is x greater and equals 5 and less than and equals 10. And from here we know the value of L is 10. So we take the previous equation and we substitute the value of x, so we will get this equation. And we know this is Fourier sine series, and we includes the equation here and we substitute, and then we substitute the value of x, and lastly we will get this equation. Okay, for the second boundary condition, which is when t is 0, and we know when t is 0 it is the rest time, so ut x0 equals to sine n pi x over 10, and here we substitute the value of x and we will get this equation. And lastly we know when t is 0 qn is 0, and our last equation goes u x t equals to 40 over pi squared 1 over n squared sine n pi over 2 cos n pi t over 5 sine n pi x over 10.
Assalamualaikum madam, so I'm Azwin and I'm going to explain you about question 2C, which is it asks we need to find the solution by using numerical methods. So let's start. First we have the wave equation, which is delta squared u over delta t squared equals to 4 times delta squared u over delta x squared. And then we also have boundary condition from Amy's part and initial condition from Amy's part 2. And then, so we know that by using centered formula, given h equals to 1 and k equals to 1 over 4. So, first of all, we need to sketch the grid point, which is like this. It looks like this. So we name the coordinate like u10. So this is for stand for I and j. So u10, we can look at this 1 and 0, u11, u12, u13, and so on. So carry on, proceed it. And then the second step is we have the utt equals to 4uxx. This is similar with this one, the general solution. Yeah. So we move this 4uxx into the left hand side, and then equals to 0. From this equation, we have to make it like this: delta squared u over delta t squared ij minus 4 times delta squared u over delta x squared ij equal to 0. Then from the centered different formula, we know that the equation will be like this: uij plus 1 minus 2ij plus uij minus 1 over k squared, and minus 4 times ui plus 1 j minus 2uij plus ui minus 1 j over h squared equals to 0. So from this equation, we have to substitute the value of k and the value of h, and then it will become like this. So after we resubstitute the value, then we need to make ui j plus 1 as a subject, and all of it we have to move it to the right hand side. So by using control different formulas, du over dt x1 0 t at t equal to 0, it equals to du over dt ij equal to 0. It means j will be 0. So we will get this ui j plus 1 minus uij minus 1 over 2k. Then we substitute k, the value of k, then we get ui1 equals to ui minus 1. So the next part is k. So we have to find uij plus 1. And then the condition is when I equals to 1 and j equal to 0. So substitute 1 and 0 into the equation that we already set. So this is it will be 2u1 0 minus u1 minus 1 plus 1 over 4 times u2 0 minus 2u1 0 plus u0 0. So based on this, we can look at the grid point, which is this. So we just substitute the value, and then you can get this. And then so as we know, u1 minus 1 is equals to u11 here. So the substitute, we move this u11 into the left hand side and then plus with u11 here, so that we get 2 u11 equals to 2, because 2 plus 0 is 2. So u11 equals to 1. Okay. And the second, we try to get the when I equals to 2 and j equal to 0, so we have to find u21 punya coordinate lah. And then substitute as well, look at the grid point, substitute the value, make sure that make sure we reduce the error, the careless error. So we got u21 equals to 2, and for u31 is the same method as the above. So we got u31 equals to 13 over 4. Then carry on using Microsoft Excel like this. Ta-da! So this is the value, the analytical value, a numerical value. Okay, so we got this. And then next, the question asked to find the percentage relative error, which is the formula is actual value minus expected value over actual value modulus times 100%, because it's a percentage. So as we can calculate like this, to find the actual value, we already given the fx, the function, so we just look at the range. For this part, x, the function will be x if the limit is from 0 until 5. So when 0 until 5, if we want to find the u12, so we look, the x is 1, so the fx is x, the function is x only. So we got substitute, so x will be 1. This is for the analytical, the actual value, and the approximate is at u12 is equals to 0.998264. It's based from the grid point that we already construct in the Excel. And then when we got this, so we minus it, and then times 100, and we got 0.1736%. Then carry on. This is not, no. Carry on. We got answer, and then we can type this. We can key in this formula. So that's all from me. Thank you.